This is a study on the League of Legends graphics pipeline. To start, we need to know what rendering is and how it works. What happens is the GPU gets triangles and textures and displays them as pixels using a pixel shader. These shaders do things like calculate texels, add or multiply textures on a triangle, or apply bump maps, lighting, reflections, and shaders. This is an example of rendering. Take the first picture of the character model, apply the texture below it, and get the result of the animation you see at the bottom. The first stage is rendering the fog of war. There is a picture in the CPU that is upscaled and blurred. Depending on how dark parts of the texture are, will determine the fog in the game. For shadows, we render them from the point of view of the light source. Then, with a depth buffer, find the distance from the light and cast them to a shadow field that holds their height. We then blur the shadows and layer them onto the static geometry. Static geometry is stuff that will never move and never need their shadows updated, like the map. It is a combination of the fog of war as well as object shadows with its texture underneath. Skin meshes are essentially all moving objects. We animate them using bones. Shader also calculates lighting. Outlines are done to make meshes stand out in the background of the scene. They're calculated using the scaled depth of the mesh, and using a Sobel filter to get the edge, which is then rendered over. Grass is simply a skin mesh that has its shaders drawn as a part of the texture of the mesh. Water is animated through putting translucent mesh animations for waves and ripples around objects like rock. Decals are flat geometry that are layered over everything else we currently have. In the picture below, the red circle surrounding the turret is a decal. Partial outlines are very similar to the outlines we talked about earlier, although they are blurred to make them thicker, as well as render them later in the pipeline to draw them over the other outlines. For particles, we create triangles for the particles to be rendered on, then apply texture to those triangles and draw it on the scene. Post-processing effects have two main stages. The first one is anti-aliasing, to make edges look smooth, get rid of pixel shading. The second is gamma correction pass, which is used to adjust the brightness of the scene, as well as optimize the game by taking care of things like desaturation. Damage and health bars, as well as other things like announcements, are dynamic UI for the player. Everything related to the HUD is a texture that is individually drawn to the screen in the last step, overlapping anything behind it. And that is everything together.